Well, thank you everyone for coming to this talk. I would like to present generative AI, human creativity, and art. This is a joint work with my student Eric Zhou. You can find a copy of the paper at tiny.cc/genart. So last year, text-to-image AI model Midjourney has been used to win an actual human art competition. And the judges did not know about it until it was released and the first prize was won. It has gotten, right now the text-to-image model has gotten up to a point where we cannot really distinguish if it was human generated or AI generated, but it all started around 2017. The first of its kind was Attention GAN. Then DALL-E 1 came about in 2021. It didn't make a big news, but not a lot of users actually used it. It was never released, but some people estimate that it's tens of thousands. It wasn't until Midjourney, DALL-E 2, and Stable Diffusion, all within a few months of each other in 2022, the text-to-image model has been massively adopted. Lots of artists, whether pros or non-pros, started using this tool and sharing the outcomes and using it for jobs too. So Midjourney had about 15, as of this recording, about 15 million users. DALL-E 2 had 2 million, and Stable Diffusion about 10 million. And DALL-E 3 is coming out soon. Our work is highly relevant and close to relevant to computational creativity. So early work sought to understand philosophical nature of creativity. For example, how can computer-generated artifacts be valued as creative work? Can AI agent recognize and create a creative artifact? Or should that be left alone? Even now, there are discussions on this. And in this literature, two widely used criteria for creativity, you need both, first one is novelty. How different an artifact is from a known artifact in its class, or how different is it from known universe of artifacts that's instantiated. And then there's the value part, which measures its utility, performance, or attractiveness of an artifact. It can be utility or attractiveness or performance, and it's very contextual dependent, and it varies. So our research questions are as follows. How does adoption of generative AI, in this case, text-to-image models, affect humans' creative productivity? Second, is generative AI enabling humans to produce more creative content by novelty and value? And third, and most importantly and interestingly, for whom and when is generative AI effective? When does co-creation lead to value? And we explore all these in our research. So our empirical setting is an art sharing platform, about 5 million posts, spanning about 50,000 unique users, and at least around 6,000 known AI adopters with 1.5 million images. This is double-digit terabytes of data, and we're still collecting the data. And in this website, they basically ask the users if they do use text-to-image or AI tools, that they're strongly encouraged to reveal that. And some people do, the users do, via titles and tags. And policy requires it, but policy doesn't mean it's implemented. And a lot of times, actually, many people don't tag it, even though it is AI generated. So we had to build this model, custom multimodal AI image detector, which took a few months. And it's very hard because you would have to actually train and generate different different models, text-to-image models, and then use those training data set. But we did so, and here's our multimodal classifier. First of all, if it was published after January 2021, then we entered into the multimodal classifier. If not, this is before widespread of the text-to-image model, so this is not AI generated. And once it passes that it is after January 2021, then we use NLP-based classifier that uses description and tags as attributes, and then try to predict. If it is AI, then that's that. If not, then if it's unclear, then we then put into visual inspector based on Dino V2, which is released by Meta, and it was ranking one in a bunch of different benchmarks. So we chose this, and we used Dino V2 to actually look at and classify the images at the pixel level. We had gold data set that we either generated or was supplied from the website based on user revealing themselves. And we use all of that to create this model to predict the ones that they did not release. Right? So for example, the best model here, it achieved a test accuracy of 92%. Here's a descriptive visuals of our adoption timeline, the users in our data set. Midjourney has been released in 2022 March, DALL-E 2 here, and then majority of them adopted after that, and you can see this graph. Our identification strategy to study causal part is event study difference in difference by Callaway and Santana from 2021 using doubly robust estimation. The assumption is that AI adoption for different users happen at different times with a heterogeneous treatment effect. For example, early adopter is systematically different from late adopter, and so we will try to control for that. And so this method basically makes a distinction between the controls who never adapt, and then the treated who will eventually adapt, and then the treated at the time. And each different timeline, it estimates the impact, carefully dividing the control and treated, and then aggregates them later on. So we also balance panels by estimating propensity score model based on observable features that correlate with user activity level, and so on and so forth. We also, in the paper, you'll see that we also confirm this with a synthetic control method, same result. Here's the outcome variable. The Y variable, simple measure of productivity, is log of monthly number of posts. And value in this case is actually defined for us. It's favorites per view. We have to control for view. And the novelty is a pairwise distance for each artifact compared to all prior artifacts. And we operationalize this in two different ways. So humans can express creativity via two main ways in digital artifacts, content and visuals. Content concerns the focal object, what's in the picture, and the relationship between the objects. So that's content, actual what's being described in the visual. Then there is a visual novelty or content, which is basically, it considers the stylistic and thematic element of artifact at the pixel level. Right, so here are some 2x2 showing, well, this is same content and visual. You can see they look the same. It's both cat. In this case, they're same content because they're both cats, but different visual. This one on the left is more like steampunk, cyberpunk, got a visual. On the other side, on the other one, it's a bit more, I don't know what that is, but different visuals. And then we have a same visual. They both kind of look like some sort of a steampunk or cyberpunk visual or animation. Different content because this is a woman and this is a cat. This one has both different content and visuals. So this is how we operationalize. For content feature extraction, we actually used Blip2 from Salesforce, which is image to text. So it is able to describe what's in the picture. Obviously, it is more objective than humans, getting it from humans, because it learned to do this by looking at all kinds of human-generated data. And it has looked at more images than any human beings could. Now, once Blip2 generates the text, we then find the text embedding, and we can take a pairwise cosine distance. For example, this one is closer to this cat-looking one compared to this mushroom cloud. Here's another example. Waterfall is closer to mushroom cloud than, say, cat. And this is the visual feature extraction. We use Dino V2 from Meta. Dino V2 relies on self-supervised learning approach to flexibly extract visual feature at the pixel level. You can see here the cosine similarity between these two ones are quite similar, less similar. And as you go down, mushroom is very dissimilar to this picture. All right, so data exploration. Here's a case study with a user. This user in June of 2020 mostly created Pokemon game graphics. Um, and then there was a hiatus. Come September 2022, the user launched and restarted saying it's new and improved. And then we find out, AKA, he or she adapted text to image model. And since then, been creating these kinds of all kinds of different looking visuals and posting them. This is sort of what happens. And here's our most novel content in our data set. Of course, we just selected randomly at the top. So you can see fractal landscape, transmagnetic, transmagentic excitation field. So the content is quite novel compared to other things. And this is the least novel content, mountains, not so novel, what's in the object, right? And then some portrayal or portrait. In our data set, this is also most novel visually at the pixel level. You can see like lots of different colors. There's iridescence. Visually, also the style seems a bit novel compared to the least novel visual artwork that looks like something that we have seen in a museum over and over again. And this is the most valuable. So the one on the left side obtained about 0.613 favorites per view, one view. So 61% of being favorited given view. And then the next two ones are least valuable. They both obtain 0. Someone actually uploaded a Shutterstock photo. All right, now back to the actual result. We show that there's a significant lift in creative productivity within the first several months. So first month, it increases by 50%. Second month, it reaches up to 100%, and then it stables off to about 25% in a few months after. For an average adopter, this amounts to about 7 additional posts during the first month. Second month, 15. And then following months after that, starting second, third month, and so on and so forth, to about 3 to 4 additional posts per month. So it increases productivity. Here is an output for value. We measured value as favorites per view, and there's an overall significant increase, overall 1% increase in the likelihood of receiving favorites per view. This doesn't seem like much, but if you think about on average, this translates to about 50% increase over pre-treatment value rate of 2% favorites per view. So average picture gets, every time it was viewed 300 times, it gets 2 favorites, but then adopters now, that increases to 3%. So it's a 50% increase. Now, average content novelty decreases over time. You can see a consistent decrease in average content novelty. So what people are portraying the same thing. And the adopters actually, the average content novelty is decreasing. On the other hand, despite average content novelty decreasing over time, max content novelty suggests exploration and expansion of creative landscape. So over time, the max average content novelty actually increases. You can see increase in the max novelty increasing, right? So while the creative landscape is overall increasing, there is some inefficiency where people are creating same content over and over again. This is what it's saying. On the other hand, visual average novelty decreases over time. Both the average and the max decrease over time. Okay, I didn't include max one here, but you can see it on paper. Both of them consistently and very clearly goes down over time. But then the question is, who is actually winning? And when is it working? What kind of novelty translates to value? So we approach this, we explore this, we examine this. So generative AI decreases content and visual novelty in aggregate, although it increases the max content novelty. For whom and what type of novelty bring value? It's what we explore next. So we again here in well, not again, but we bucket adopters based on quartiles: bottom, lower, upper, and best quartiles of average pre-treatment content and visual novelty. So what we did was we bucketed them before their based on their pre-adoption ability of being contently novel or visually novel. Then we estimate the effect of skill tiers interacted with mean novelty scores using two-way fixed effect. Okay. So here's the result. So think of pre-treatment content novelty as the artist ideation ability. You can see here the y-axis is the estimated effect on value, and then the x-axis is just different quartiles, right? Content creativity prior to treatment. You can see that almost all of them benefit from good content novelty. So no matter how good you are before, better content or ideation ability brings you more value, right? As opposed to that, visual novelty seems to be penalized, except for weak positive for the bottom quartile. Here we have the same results for pre-treatment visual novelty. You can think of this as a artistic execution ability before the adoption, right? Again, here you see that all groups benefit from good content novelty. But previously, the best visually novel artist reaped the best benefit. So they were pretty good at coming up with novel visual before the adoption. And after, if they increase the content novelty, obviously they benefit better because that probably follows with the good visual good visual novelty as well. On the other hand, if the most mechanically skilled artists are more novel, it's actually penalized. It's sort of reminiscent of the upside down U curve. If you're too novel, then maybe people don't like it as much. Okay. And so what we did here is we predicted the value based on either visual novelty or content novelty. And then we used the SHAP to put a predictive attribution on these visual novelty or content novelty. You can see here as the time goes, months since the adoption on the x-axis, the SHAP value of the content novelty increases, which means that as time goes, content novelty is highly more predictive or has a more predictive value for that value as measured by favorites per view. So in the land of Midjourney, content is king. Lastly, we also explored where the value capture happens. Who's capturing this value as a result of adopting this text-to-image model. So value captured here, again, is just we define as favorites earned, and then we can get the market size per user, right? And then we can calculate the Gini coefficient. So here you can see that compared to Gini coefficient of not yet adopted treated group, the treated or the adopted one showed decreased concentration overall. What this is saying is that adopters, the group that adopted, the value distribution or value spreads across the users, meaning before the adoption, the group is more concentrated, the favorites were more concentrated. And once people start adopting, the value capture or favorites earned actually gets spread out more. There's less concentration. So AI is equalizing value capture at least in our data set. So here is our summary. Takeaway is that productivity increases by 50% on the first month of adoption, and it converges to a stable level of 25% over time. Value also increases, measured by favorites per view. It's interesting because average content novelty decreases over time, but max content novelty increases, suggesting expansion of creative landscape. And average visual novelty, both the average and max novelty, visual novelty decreases. Winners and losers are divided. The value capture, however, it's equal. It gets more equal. I would like to talk about how this interaction between humanity and generative AI is causing sort of generative synesthesia, where people can use their senses to dream up all kinds of wonderful pictures. And that is it. Thank you for listening.